All right, so we have a competency test coming up, and remember that is material that you're technically supposed to know before beginning this course. And so I'm going to go over some of those highlights, but just know there are going to be some things that you are expected to already come into this class knowing. Okay, it's a college level class, and so we expect you to have had, classes in the past, whether that be in high school or whether that be an intermediate algebra class that kind of gets you ready for this one. So we're going to look at some of the competency exam material, but not all. You're going to be responsible for that kind of on your own. But I do want to look at some of the more commonly forgotten topics. Okay, so the first one that we expect you to come to this class kind of already knowing how to factor. Factoring is just at its core looking for what terms have in common. Okay, so you might get something like this, where you're asked to factor 2x squared plus 4xy plus 6y squared. Okay, so if you were asked to factor this, we don't really know a whole lot about factoring with x's and y's, and we're not really going to need to do that, but we can at least notice that, hey, I think all three of these terms have a 2 in them. So if you divide a 2 out from the first term, you would have x squared. If you divide a 2 out from the middle term, you would have 2xy. And if you divide a 2 out from the last term, you would have 3y squared. Okay, so sometimes factoring is just that simple. Okay, it is pulling or dividing out what all of the terms have in common. But most of the time when we ask you to factor something, we're speaking about a specific type of expression called a trinomial. Okay, well that technically is a trinomial because trinomials means 3 terms. But more specifically, we're going to be spending some time on questions that look like this. A number times x squared plus another number times x plus c. Okay, so in other words, a, b, and c are just going to be numbers. And at this university, we typically use the AC method to teach that. If you have a method from another math teacher that you are more comfortable with, I'm fine with you sticking with that. Okay, I'm gonna give you instruction based on the AC method. You can use whatever method you would like. All right, so here are the steps of AC method broken down, and then we're gonna look at some examples. First, you're gonna multiply a times c. In other words, multiply first number times the last number, the constant. Step number 2 is you're gonna list all factor pairs of that number a times c. Okay, something that a lot of students typically forget is that a lot of times, or all the time actually, you will have 2 sets of numbers, okay, and you will have some negative values you have to kind of think about. Okay. Step number 3 is probably the most important step of the whole process, so that's why I put a star by it. So next you're going to choose the factor pair. That adds up to b, or the middle term. Okay, the middle number, that's what this symbol means in math. And I want you to replace the middle term with 2 terms using the pair you just chose. So you're going to be expanding out your original expression and splitting that middle single term into 2 terms. And then last but not least, you're going to do a process called factoring by grouping. So we teach AC method here because although it's a little bit longer process to learn than maybe some of the others, if something is factorable, it works every time to factor an expression. So that is why we like it, and that's why we tend to use that here. So let's say that I asked you to factor the following: 12x squared minus 17x plus 6. Okay, so we're going to run through the steps. So step number 1 is going to be to multiply a times c. Okay, so we're going to do 12 times 6, which is 72. Okay, so step 1 is very, very short, very brief. All right, so step 2 is you need to list all the factor pairs of 72. Okay, all the numbers that multiply to give us 72. Okay, especially when the number is a little bigger and there are a lot of factors, you're going to want to go in some sort of order so you don't forget them. So I like to start with 1. 1 goes into every number, right? So 1 times itself would always be any number we wanted. 2 goes into 72 36 times. If you need to pull out like a basic calculator just to get these multiplications, you can. Okay, so 3 times 24 is 72. 4 times 18 is 72. 5 doesn't go into 72 at all. Okay, but 6 does 12 times. 7 doesn't go into 72 at all, but 8 does 9 times. Okay, and then once I get here, I know that I'm done kind of with the distinct list of pairs, because notice if I go in order, the next pair would be 9 times 8, and it would be a repeat of what I already did. But I also need to remember that a positive times a positive is a positive answer, but also a negative times a negative is a positive result also. So I have all these same numbers, just the negative versions. Notice in all of these examples, they're both negative, right? If only one was negative, that wouldn't work because we would get a negative 72. Okay, but a negative 6 times a negative 12 is positive 72. So is a negative 8 times a negative 9. So that's what I meant back up in step 2 when I said don't forget the negatives. Okay. So step 3, okay, is I want to choose the pair, and there'll only be one, okay, that adds up to 17. Excuse me, negative 17. Okay, and remember, negative 17 is the middle number. Okay, the fact that we want it to be negative 17 tells us that we're going to be in this column, right? So we want to go down the list and find the pair that adds up to negative 17, and notice this is the one that's going to work, right? Okay, negative 8 and negative 9 are going to work. So I'm going to choose negative 8 and negative 9. Okay, but then I'm still, I still have some of step 3 left. Okay, so here was my original, 12x squared minus 17x plus 6. Okay, but I want to replace this term, this middle guy right here, with 2 terms using negative 8 and negative 9. Okay, but I don't want to change the value of anything. So this would be 12x squared minus 8x minus 9x plus 6. Okay, so notice, negative 8x minus 9x is negative 17x. So I haven't changed the value of anything. I've just expanded out this middle number into 2 numbers so that I can do what's called factoring by grouping. Okay. All right, so factoring by grouping looks like this. You group the first 2 terms together and the second 2 terms together, and you kind of see what you can get there. So in other words, I'm going to ask myself, I'm going to cover this up with my pen here. So what could I pull out or factor out of the first group that they would have in common? Notice they have a 4 in common, but they also have an x. So I'm going to factor out a 4x or divide out a 4x. If I divide 12x squared by 4x, I get 3x. If I divide negative 8x by 4x, I get minus 2. Okay, so the first group is completed. Okay, so now I'm going to focus on the second group. So I'm going to cover up the first group. Okay, so now you're asking yourselves, what do the second 2 terms have in common? Okay, notice they do have a 3 in common, right? Anytime this is negative, we're going to want to actually divide out a negative number. So we're going to say a negative 3. So a negative 9x divided by a negative 3 is a positive 3x. A 6 divided by a negative 3 is a negative 2. So now notice we have 2 groups, and each of those 2 groups have a 3x minus 2 parentheses in common. Okay, so our answer ends up being pull out or divide out what the 2 groups have in common, which is 3x minus 2. And then if you were to pull out those pieces, what would be left? And that would be 4x minus 3. Okay, so this is my factored version. Okay, it's a little bit long of a process to learn, but once you do, it really makes a lot of sense, and anything that can be factored can be done using this method. Okay, if you're a little bit shaky on factoring, or if you just need to refresh your memory on factoring and how to check your work, you can always check your factored form using the 4-step process FOIL. Remember, FOIL stands for first, outside, inside, last. And there's actually a FOIL question on your comp test too, so we're going to kind of review that here. Okay, so you would just do first times first, so 3x times 4x, which is 12x squared. Okay, and then 3x times negative 3x outside would be negative 9x. Negative 2 times 4x would be negative 8x. And then lastly, negative 2 times negative 2 would be positive 6. Okay, notice these 4 steps are FOIL. So kind of ran out of space here, but that's okay. So in the end, we end up, if we combine like terms, we get 12x squared minus 17x plus 6, which was exactly what we started off with, right? This is our original. Okay, so you don't have to do that on every problem, but while you're kind of getting ready for your comp exam, and if you're just not sure on the comp exam that you factored it correctly, you can actually know that you factored it correctly if you just check it real quick using FOIL. Okay. All right, so once you get the hang of this, you can kind of shortcut it if you like. So if you're not comfortable in making the shortcuts, you don't have to make these shortcuts, but it can definitely save you some time. Okay, so let's say that we're given another problem, maybe this one. So let's say you're supposed to factor 6x squared plus 5x minus 4. Okay, so we're going to run through the AC method. We're just not going to show as many steps. So 6 times negative 4 is negative 24. So here is your thought process at least. Whether you write this down or just think it, it's up to you. Okay, but I want a factor pair of negative 24. But I also want it to add up to 5. Okay, so a number that multiplies to give me negative 24, but at the same time adds up to give me 5. Okay, so you can spend the time listing all of those. Notice we have 1 and 24, we have 2 and 12, we have 4 and 6, okay, and we have 3 and 8. I almost forgot the one that works. Okay, so I'm going to make sure, by the way, this is a negative 24, so that matters, right? That means one of the pair is going to be negative and one of them is going to be positive. Okay, so I'm going to choose 8 and negative 3. Okay, and why did I choose that? Note, the reason I chose that is because 8 times negative 3 is negative 24, but also 8 plus negative 3 is 5. Okay, that's why I chose that pair. Notice I couldn't have said negative 8 and positive 3, or it would have added up to be negative 5, and that's not what I want. Okay, so here's your original. 6x squared plus 5x minus 4. Okay, and remember what we're doing is we're changing this middle guy to be 2 parts. Okay, so this is going to change to 6x squared plus 8x minus 3x and then minus 4. Okay, so I'm circling the pieces that are changing. And again, just like with the last one, you could say negative 3x first plus 8x as long as the 8x is the positive one. Okay, so we're almost there. We're going to factor by grouping. So group first 2 terms together and last 2 terms together. So notice a 2 could come out of the first group, a 2 and an x. So if you divide by 2x, you'll get 3x plus 4. Okay, notice here, there's no number other than 1 that goes into 3 and 4. So we're just going to use 1, but the fact that this is negative means it actually needs to be a negative 1. So if you divide numbers by a -1, you actually don't change the value, you just change the sign. Okay, so notice now we have similar parentheses there. So I end up getting 3x plus 4, and then the leftover is 2x minus 1. Okay, so remember you can use FOIL to check if you like, but we won't do that here. Okay, but you could always use FOIL to check it. Okay, sometimes though you might get a factoring question that maybe you think we don't need the full-blown AC method for. Okay, so let's look at one like that. So let's do x squared plus 5x minus plus 6. Okay, notice the difference between this problem and the two before it is that the coefficient in front of x squared is 1. So in this case, we can actually just fast track this. In other words, if we do a times c, we're just going to get the value of c anyway. Okay, so really we don't need to worry about a since a is 1. Okay, so really you're just looking for factors of 6 that add up to 5, and then you can actually just write it as your answer and be done with it. So notice the factors of 6 that add up to 5 are 2 and 3. Okay, so that would actually be all you would need to do there. Now, if you decided to go through and do the AC method, you would still get the same result. Okay, I'm just saying when the number in front of x squared is 1, you might not have to go through the full-blown AC method. Okay, but to be honest with you, the one on the competency test is going to be more like the example 2 or example 3. I probably won't put one quite this easy on the competency test. Okay, but throughout this semester, you'll encounter things like this, and you should be able to factor those a little quicker. Okay, so let's look at some more what I call special case factoring. So I want you to be able to recognize some special cases and factor those quickly, just kind of by observation. So there is a special kind of squared question that is actually just the difference of two squares. Difference means subtraction. So if you end up getting something like this, where you have something squared minus something else squared, the factorization for that is always square root of the first plus square root of the second, and then square root of the first minus the square root of the second. Okay, so what that means is if you can verify that you have a special case, then you shouldn't have to really show a lot of work. You should just be able to factor this quickly. So notice this looks different than the ones we factored before, right? Because there's no middle term. Okay, also notice we are subtracting. Okay, and then notice these are two perfect squares, right? This is literally x squared, right? But this is also something squared, right? This is 8 squared. So the factorization of that is simply square root of the first plus square root of the second, and then square root of the first minus the square root of the second. Okay? And just so you know, you can check these with FOIL too. If you FOIL this out again, you're going to get your middle two terms are going to cancel out. You're going to get negative 8x plus 8x. Okay? So what about one that looks a little uglier, but actually the process is much the same as it was in example 5? Okay, so first thing, we are subtracting, so it is a difference. Okay, so you just need to verify that these are perfect squares. And notice 100 is a perfect square, right? So this is going to be 10x squared, right? Because if 10 squared would be 100, x squared would be x squared. But this is a perfect square as well, right? This is actually 9y squared. So now that we've verified that we are subtracting and that we have two squares, we can use the difference of squares formula. So it's square root of the first plus square root of the second, and it's square root of the first minus square root of the second. Okay. All right, so when you see that, I want you to be able to recognize that and be like, you know, I know how to do that. I can go ahead and factor that quickly. So the second thing that I want to look at is reducing roots. All right, so basic roots we already know how to do, hopefully. Okay, so when I ask you to take the square root of 25, we know already that the answer is 5. But why is it 5? That's going to be kind of important. It's because 5 times 5 is 25, right? Maybe we're a little less comfortable, but it's not always a square root. Okay, so when I ask you for, sorry, that's supposed to be cube root, so that should be a 3. I know that's really sloppy, but cube root of 64. Notice this time we're looking for what times itself 3 times gives us 64, and the answer here would be 4. But the reason behind it is because 4 times 4 times 4 is 64. But what do we do when the root is more difficult to find? And the answer to that is we can always typically do a piece of the root. And so when we can't find the entire root, we're just going to try to do it in stages. Okay, so let's start with just a number here. So if I asked you to find the square root of 120, okay, notice that is not going to be a nice number, right? This is not a whole number answer. So I'm going to say this is not a perfect square. But it doesn't mean we can't reduce it in some way. It just means it's not going to come out to be a whole number. Okay, so how we are going to do that is we are going to break 120 into its smallest pieces using a factor tree. Okay, so what we need is we need 2 numbers that multiply to give us 120. So anything that ends in a 0, I know that 10 goes into it. But I'm going to keep breaking down the pieces of this tree until I can't do it anymore, right? So 2 and 5 are done. I can't break down 2 and 5 anymore. Those are actually prime numbers. 12 I could break down into 3 times 4. And then 4 I could break into 2 times 2. Okay. By the way, you don't have to use 10 times 20. You also could have used 2 times 60 or 4 times 30. And you would have gotten the same final answers here. Your circled numbers in the end would have been the same. Okay, so the square root of 120 broken down into its smallest pieces is 2 times 2 times 2 times 3 times 5. Okay, no matter how these are scattered, try to put them in numeric order when you write over here. Okay, and because it's square root, we're actually looking for groups of 2. Okay, so notice we only have one pair, right? We have a pair of 2s. So think of it this way. I'm going to cover these up. 2 times 2 is really 4, right? So the square root of 4 is 2. So another way to think of it is anything that is part of a group is going to get pulled out, okay? So because there are 2 2s, I have one group of 2, okay? But anything that is not part of a pair is going to stay inside. So 2 times 3 times 5 is going to remain. And so the reduced answer is actually 2 square root of 30. Okay. Another way to think of it is basically we split up 120 into 4 times 30. And we took the square root of 4, which was 2, and we left the square root of 30 because that's not something that we can do and get a whole number answer. Okay, so the factor tree just allows you to kind of quickly determine what should come out of the square root versus what should stay in. Okay, so let's look at a cube root problem. Cube roots are really not that much different. Okay, we're still going to factor tree and break down the number into its smallest pieces. Okay, so again, if it ends in a 0, we know 10 goes into it. So this breaks down into 2 times 5, and this breaks down into 5 times 5. Okay, so the cube root of 250, not really sure why I wrote that again, is the same as the cube root of 2 times 5 times 5 times 5. Okay, so notice I just pull out the prime numbers that I got in my factor tree. Okay, but this time the only change, okay, so far we've been doing the same thing. The only change is this time I'm looking for groups of 3. So honestly, the only difference between doing square roots and other types of roots is really in the very last step. Okay, so I'm looking for groups of 3, and notice I only have one group of 3. So in the end, I have a group of 3, and I'm going to leave inside the 2 that didn't get grouped up. Okay, so the reduced version of the cube root of 250 is actually 5 cube root of 2. Okay, so what about when you are given something like this with some x's in it? Okay, so we're not going to make this harder than it is. We're just going to do the same thing we've been doing. We're going to split up everything into its smallest pieces, and we're going to see what kind of groups we have. Now, we're doing square root, so we're back to groups of 2, right? So first things first, let's factor tree 300. So it would be 3 times 100. 10 could be 10 times 10. But then each of these would split into 2 times 5. So it doesn't really matter how you split them up. Just make sure you don't stop until you have prime numbers. Okay? But here's what I've got. And this is going to seem a little tedious, but I promise there's a purpose. So I have 2 2s, a 3, and 2 5s, it looks like. Okay? But now I have these x's, right? So x cubed means I have x times itself 3 times. Y to the 4th means I have y times itself 4 times. Okay? And now, no different than what I did before, I'm looking for groups of 2. Any group of 2 is going to come out. Anything that is not grouped up is going to stay in. So I have a group of 2 here. Here. I have another one there. And then I have 2 more here. Okay, so anything that's part of a group is going to get pulled out, and then we'll mess with it in a minute. So we're going to pull out a 2, a 5, an x, 2 groups of y, right? And then what's going to stay in is a 3 and an x. So in the end, we just kind of clean this up. 2 times 5 is 10. X is by itself. Y times itself is y squared. And the 3x still stays in the inside. Okay. So kind of like I said before with some other things, I don't care if you do a simplification problem in this way, but I think this is a really good way for you to not forget anything, okay, and for you to kind of keep everything straight. All right, so that's kind of reducing roots. Okay, so next let's look at the quadratic formula. Okay, so the quadratic formula is basically for solving quadratic equations such as ax squared plus bx plus c equals 0. Notice that's kind of the same format that we used when we factored using the AC method. So the a, b, and the c are the same. Okay. This works all the time, but we're going to mainly use it when factoring doesn't work. So the quadratic formula that you will need to know is negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so let's look at some examples here. First thing is, on the comp exam, you're going to be told when to use quadratic formula, but in the course of this class, you may not be told that. So we're going to talk about why we wouldn't even be able to factor even if we wanted to here. Okay. Note that the AC method doesn't work here, because think about what you would do, right? You would be looking for factors of negative 13, because 1 times negative 13 is negative 13. So no factors of negative 13 will ever add up to 4, right? Because the only thing that gives you negative 13 is either 1 times negative 13 or vice versa, negative 1 times positive 13, neither of which would ever add up to 4, right? So factoring wouldn't even work here anyway. So I like to lay out what A, B, and C are ahead of time so that I plug the right numbers in. Notice there's no number given here, right? So it's an understood 1. Okay, B is 4, C is negative 13. So my x is going to be negative b plus or minus the square root of b squared minus 4ac, and then all over 2a. Notice as I said the quadratic formula, I went ahead and plugged in the appropriate numbers, right? A was 1, b was 4, c was negative 13. Okay, so then you just need to remember your arithmetic, like which part of this many operations should come first. And exponents come first, so 4 squared 16 minus 4 times 1 times negative 13. If you are confident, you might be able to combine some of these steps, but I like to show the different steps on the video so that you can make sure that you don't mess up anything. By the way, notice this is a positive 16, but even if that would have been a negative 4, even negative 4, if you times it by itself, is a positive number. So this piece that I'm pointing at should always be positive. Not everything, okay? You might have a negative answer in the end, but the part right here where you have b squared should always be positive, okay? So now let's multiply. That's the next step in the order of operations. So I've got 16. Negative 4 times negative 13 is positive 52. And then 2 times 1 is 2. So I end up with negative 4 plus or minus the square root of 68 over 2. Okay, this is the correct answer, but it is not fully simplified. Okay, so think of it like equivalent to you putting an answer of 2/4 when you really should simplify that to 1/2. Okay, so we're going to simplify. More specifically, we're going to see what we can do with this guy. Okay, see if 68 can be broken down in some way. Now we know it's not a perfect square, but maybe we can factor tree it and take out a part of it, right? So anything even, we know 2 goes into it. So you can use your calculator for this if you need to, okay? But square root of 68 broken down into its smallest pieces would be square root of 2 times 2 times 17. Okay, notice that we have a pair, right? We have a group of 2. So the group of 2 comes out while the 17 stays in. So this is what we end up getting, negative 4 plus or minus 2 square root of 17 over 2. Okay, but that actually still can be simplified further. Okay, we can only simplify a number from the bottom to the top if we have that number present everywhere. But notice we do, right? A 2 here, a 2 could be pulled out of here, but there's also a 2 here. There would have to be a 2 in all 3 spaces for us to be able to do this. But 2 divided by 2 is 1. 2 divided by 2 is 1. And then negative 4 divided by 2 is negative 2. Okay, so we end up getting negative 2 plus or minus the square root of 17. That's how we write that in its most simple form. Okay, so these may not be the most pleasant answers in the world, but it is 2 answers. Okay, so for MyMathLab, it's actually going to want you to list those separately. So usually MyMathLab has you list different answers separated by a comma. So you would type in negative 2 plus square root of 17, comma, negative 2 minus square root of 17. Okay. Okay, so let's say that rather than you trying to factor this, let's just say that I asked you to solve this using the quadratic formula. Now this actually does factor. Okay, but we're going to practice the quadratic formula more and talk about kind of what kind of answers we might get. Okay, so maybe off to the side, let's write that A is 2, B is negative 5, C is negative 12. Okay, so again, let's plug all this in. So it's negative B plus or minus the square root of B squared minus 4AC, and then all of that over 2A. Okay, so just like I said before, remember if you have a negative number squared, that is still positive, right? A -5 times a -5 is still 25. Now, if you're using your calculator, make sure that you put that -5 in parentheses before you square it if you want the calculator to help you out there. So what you end up getting, I'm going to kind of combine steps on this one. So do 5 squared first, which is 25, or -5 squared rather, but still 25. And now I'm going to go ahead and do my multiplications. So -4 times 2 is -8 times -2 is positive 96. And then on the bottom, 2 times 2 is 4. Okay, so this works out to be 5 plus or minus the square root of 121 over 4. Okay, now I don't even need to factor tree this because 121 is actually a perfect square. So what I end up getting is 5 plus or minus 11 over 4. Okay, but what hopefully we know is that this is still 2 answers. Okay, so it is literally 5 plus 11 over 4, but also 5 minus 11 over 4. So in the end, we get 2 results, 5 plus 11 over 4 and 5 minus 11 over 4. Okay, that would be 16 over 4 or just 4. Okay, this becomes -6 over 4, which reduces to -3 over 2. Okay, so we always want to break down the answer into the smallest pieces that we can. Okay, sometimes that means we'll have a root left, and sometimes in this case we won't have a root left. Okay, but you're going to have to make sure that you can break it down no matter what. Okay, so to kind of save time, let's say that you were doing quadratic formula and you ended up getting this for a result and you were sure that you did it right. In other words, remember that what I said earlier, sign errors are probably the most common in quadratic formula, but let's say you're sure you did everything right and this is what you got. Okay, that is a possibility. You can't get an answer with a negative under the square root. Okay, but what you have to hopefully remember from another class, okay, is that you handle negative square roots. They are imaginary numbers. So this will be 4 plus or minus, and then how you handle this is the square root of 4 is 2, so the square root of -4 is just 2i. Okay, so I know we're not going to super love answers with imaginary numbers in them, but they do exist. Okay, well, I guess they don't exist because they're imaginary, but anyway, you know what I mean. You can get those for answers. Okay, and then 2 goes into everything, so 2 goes into this once, and this twice. So you do end up getting 2 plus or minus I, which is 2 answers, but they are imaginary. Okay, so we won't cover imaginary numbers super heavily, but just know that that is something that we will cover in a small way later on throughout the semester. So on your comp exam, you may get one with an imaginary solution. Okay, so you need to kind of be prepared for that. All right, so the fourth and final kind of main topic that I want to cover from the competency exam, and then the rest you just need to see if you can look up on your own. Okay, I'm just kind of hitting the highlights of things that I know we're going to be using. Okay, and so we have some exponent rules. The first one is called the product rule. Okay, and the product rule just says that when exponential terms with the same base are multiplied, then we want to combine them by adding the exponents. Okay, so I'm going to underline that. That's the gist of the product rule. Okay, when you're multiplying terms, you're going to add the exponents. Okay, so here's the rule in variable form. If you have x to the a power times x to the b power, it is the same as saying x to the a plus b power. But let's look at an example. So that means if you had x cubed times x to the 5th, that would be equivalent to you saying x to the 3 plus 5 or x to the 8th. Okay, so the word product, by the way, means multiplication. So that's for when you're multiplying terms with exponents. Okay, the second rule is called the quotient rule. And what this says is that when you are dividing exponential terms with the same base, then you subtract the exponents. Okay, so here's the rule. If you have x to the a power over x to the b power, it is the same as x to the a minus b power. Okay, so an example of this might be if you had x to the 10th over x squared, you would subtract the 10 and the 2, and so you would get an exponent of 8 there as well. Last but not least, we have the power rule for exponents. And so this just says when you're raising an exponential term to another power, you're going to want to simplify by multiplying the exponents. Okay, so the power rule says you multiply the exponents. So here's the rule. So if you had x to the a and then you raised it to the b power, that would be x to the a times b power. Okay, so an example might be if you had x to the 4th and then you cubed it, that would be x to the 4 times 3 or x to the 12th. Okay, so some things to remember, and then we're going to kind of combine these rules together. So negative exponents indicate fractions. And then also anything to the 0 power. So anything at all, if you raise it to the 0 power, is always 1. Okay, so an example here would be if you had x to the negative 2 power, x to the negative 2 power is the same as 1 over x squared. Okay, that's what I meant when I said negative exponents indicate fractions. Okay, so let's do a couple of examples here, and then I think we'll be pretty much done with the review that I wanted to go over for the competency exam. Again, that means you might have to do some of these things on your own. All right, so let's say I want you to simplify this. So this is going to require that you probably use a combination of some of the rules. So we've got a lot going on there. Okay. So the first thing that we want to do is we want to recognize that we have kind of a special case here. Okay. Anything to the 0 power is actually equal to 1. Okay, so that's actually nice, right? That means we're actually going to be able to get rid of that piece. Okay. And then we want to use power rule here because notice we have powers raised to other powers. Okay, so let's go ahead and write down what we have. So we have 3 squared. Everything gets the power. So it's 3 squared, and then it's x squared. Okay, and then think about that. This is y cubed and then squared. So the power rule says we multiply those. So that would be y to the 6th. Okay, so that's what we get for the first parentheses. So I'm going to surround this because that's this first little group here. Okay, so let's do the same thing to the second group, but notice this one is a negative exponent, but that's okay. So we're going to get 6 to the negative 2 power. We're going to get x to the, remember, if it has an exponent, we need to multiply it. So 3 times negative 2 is negative 6. And then we're going to get y to the negative 2 power. Okay, I'm not even going to write this anymore because times 1 is just itself. So what these mean is these are all going to be fractions. Okay, all of these are going to move to the bottom of the fraction. Negative exponents indicate that you have a fraction. Okay, so let's go ahead and see what we have here. First of all, 3 squared is 9, so I have 9x squared y to the 6th. Okay, but then all of these got moved to the bottom, right? 6 squared is 36, x to the 6th, y squared. Okay, and again, they moved to the bottom because they were negative exponents. Okay, but now I can just do this kind of a piece at a time. I'm going to take the numbers together, I'm going to take the x's together, and I'm going to take the y's together. Okay, so the first thing is treat the numbers as you normally would. 9 goes into 9 once, 9 goes into 36 4 times. Okay, so we end up getting for the numbers 1 over 4, because the 4 is on bottom, right? And then let's do the quotient rule here, right? We would do 2 minus 6, right? So 2 minus 6 is negative 4, so we have x to the negative 4th power. But here we have y to the 6th over y squared, so we would subtract those as well, and we would get, sorry about that, we would get y to the 4th power. Okay, and then last but not least, all this means is that this guy needs to move back to the bottom of the fraction. Okay, so we're going to get a 1 y to the 4th on top, and we're going to get a 4x to the 4th on bottom. Okay, so negative exponents move to the bottom of the fraction, so I'm just going to say move there. Okay, so you should have another practice problem kind of like that one on your competency exam review that I handed out as well, or that I posted online. So just make sure that you kind of look that over. Okay, this is just one example, but it's definitely kind of similar to what you might see on the competency test.